Calculus is the study of change. No, not that kind of change.
This kind of change. You probably experience calculus more often than you realize. For example, when you're driving, your speedometer tells you your speed. That's change.
Generally, there are two types of change, average and instantaneous. Average change is easy to calculate. It's just the slope between 2 points. For example, say you leave Austin at 2 p.m. and drive 100 miles to Waco, arriving at 3:30. Your average speed was 100 divided by 1.5 hours, or your total distance divided by your travel time. While average velocity is great, it's not what gets you pulled over.
No, you don't understand. My average speed was much lower. You want me out of the car?
You get pulled over for your instantaneous velocity. This is given by a line that touches the curve at 1 point. But you'll only have a single point on this line, so how do you find the slope? Well, you kinda have to cheat by finding a new point close to your original point. This is exactly how a cop's radar works. It sends multiple pulses and calculates how long it takes for each pulse to return. They use this to get an approximation of how fast you are traveling. Interestingly, that's not how your speedometer works. It's hooked directly to your axle, giving you perfectly accurate speed.
Actually, officer, the speedometer in my car is way more accurate than your radar. You want me out of the car?
The closer the 2 points are, the better the approximation will be. A cop's radar sends out 10 billion pulses every second, giving them a fairly accurate estimation of your speed. In terms of math and equations, let's look at x squared and find an approximation of the slope at x equals 2. We'll test several values of h, perhaps we'll see a pattern. If h is 1, then our new point will be 3. Find the slope between the 2 points on the curve between x equals 2 and x equals 3. That'll be 3 squared minus 2 squared over 3 minus 2, so the slope is 5. If h is 0.1, the slope is 4.1. If h is 0.01, the slope is 4.01. And if h is 0.001, the slope is 4.001. And I think I see a pattern. If h were 0, the slope will probably be 4. And actually, this is the correct answer. That's the exact rate of change at 2.
You're probably wondering why we didn't just plug in h equals 0 to begin with. Well, when we started, we had f of x plus h minus f of x all over h. If we had plugged in h equals 0, we would have ended up with 0 over 0. And 0 over 0, we don't know. It could be anything. So that's why we have to start with saying incremental values of h.